In this video, I'm going to give you an introduction to slope. You're going to talk about the applications of slope and all of the details about slope in class. I just want to give you a quick introduction. Slope refers to the slantiness of a line. It's an incredibly technical description I just gave you, the slantiness of a line. Let's start with the basics. You'll notice that this line here slants upwards as we move from left to right. And from left to right, this line here slants downwards. We say that this line has a positive slope, and a line like this has a negative slope. Slope is often referred to with the letter M, and we sometimes call slope rise over run, which means the change in y of a graph divided by the change in x of the graph. Let me show you on the graphs of these two lines what I mean. Let's pick a point that this line goes through. Let's say this point right here, which just happens to be the point 3, 1. If we want to go to the next point to the right on this graph, the change in the y value between these 2 points is 1, 2, and the change in the x value between these 2 points is just a distance of 1. So what we do is we say the slope of this graph here has a rise over run of 2 over 1, or a slope of just 2. Let's look at this line right here. Let's look at one point on the line, let's say this one right here. And what is our change in y to get to the next point over to the right? It looks like to get to the next point to the right, we have to count 1, 2 points downwards. That's a change in y of negative 2, and a change in x of 1, 2, 3. So the slope of this line, we say, is negative 2 over 3. You can count that out all the way up and down the line. To go from this point to this point, we have to count down 2, that's a change in y of negative 2, and right 1, 2, 3. Down 2 over 3, down 2 over 3, and so on. What would a line with a slope of 3 look like? Well, let's say we started here at this point. We would go up 3 over 1, up 3 over 1, and so on. And we'd get a line that we describe as steeper. And then a line with the slope of 5 would be even steeper than that. We count up 1, 2, 3, 4, 5, and over 1. Up 1, 2, 3, 4, 5, and over 1. A line with the slope of 1 just counts up 1 and over 1, up 1 and over 1, up 1 and over 1. And that is just going to look like a 45-degree line, just like that. And let's just do one more. Let's say we have a line with the slope of less than 1. Let's say a slope of 1/3. We would count up 1 over 3, up 1 over 3, and our line would be still having a positive slope. It's still increasing from left to right, but it's a much more shallow looking line. Let's calculate the slope of a line between 2 given points, something like this. The rise, again, represents the vertical distance between 2 points. So if we're going to start at this point right here, we'd count down 1, 2, 3, 4, 5. So the rise between these 2 points is going to be negative 5. How about the run? Well, the horizontal distance between these 2 points is 1, 2, 3, 4, 5, 6, 7. So our slope is just going to be negative 5/7. Keep in mind that had we started at this point here and counted the rise over run to the point negative 4, 4, we would actually get the same answer. We get a rise of positive 5 and a run of negative 7, and we would still get an answer of negative 5/7. Well, there is another way to find the slope between 2 given points without actually having to graph it. If we want to find the vertical distance between 2 points, all we have to do is subtract their y values. So that means the rise between 2 given points is the difference between the y values. The way that we write that mathematically is we write y2 minus y1. Now the run, the horizontal distance between 2 points, is just the difference between the 2 x values. So the way we write that is x2 minus x1. So these mathematical formulas can be pretty ugly looking sometimes, I understand. So I'm going to tell you that this point here is going to be our x1, and that's going to be our y1. That means the x and y value for the first point. Right here we're going to call this x2 and y2, the x and y values from the second point. And let's see what our formula gives us. Let's see, y2 is negative 1 minus y1, which is 4. x2 is 3 minus x1, which is negative 4. Negative 1 minus 4 is negative 5. 3 minus a negative 4, that's 3 plus 4, is 7. And we still get the same answer for our slope. It's negative 5/7. Let's do another example without a graph at all. Let's find the slope of the line between these 2 points. We need to name one of these points 1 and one of these points point 2. It actually doesn't matter which we call which, so I will call this one x1, y1, and that makes this one x2, y2. Now let's just plug in our values. y2 is 6, y1 is 3, x2 is negative 2, x1 is 5. Make sure you're subtracting in both cases, and I'm getting 3 over negative 7, which is negative 3/7. Of course, if this was a fraction that you could reduce, you should go ahead and reduce it. Okay, now that we've done a couple of problems, hopefully you've gotten some basic information about slope. Here's your quiz. Find the slope of the line that I drew here. Obviously the line is not touching the points perfectly, but those points are supposed to be on the line. And then find the slope of the line between the 2 given points. Alright, good luck. I'll see you in the next one.